Hello friends, welcome to our channel. Today we shall discuss on the concept that is a curvature. So before discussing about the curvature, so let us consider some parameters. So first thing is, let us consider a curve. C in xy plane and let P and Q be any two neighboring points on it. Points on it means points on the curve. So then let us consider an arc AP is equal to S and arc PQ is equal to delta S. So by considering this parameter, we shall draw the curvature using the graph. So then let the tangents drawn to the curve at P, Q. Then we have considered the two tangents which is drawn at the points P and Q. So then once we have drawn the tangent, then we need to consider the angle of the tangent. So therefore then the angles are phi and phi plus delta phi. With x-axis, that is the angle between the tangents at P and Q. Because we are drawing the tangents with respect to P and Q points, so the angle made with respect to P and Q points is phi and phi plus delta phi. Then while moving from P to Q, through the distance delta S and the tangents through delta phi, that is the tangents at P and Q, and then while we are moving from the 2 points, that is P and Q, then the distance is taken as delta S. Similarly, the angle which is made by P and Q, that is phi and phi plus delta phi. So therefore the small change in the distance is taken as delta phi. So this is called the bending of the arc PQ. That is a change in phi represents the bending of the curve C, and the ratio, that is delta phi divided by delta S. That is delta phi is nothing but it is a change in angle, and delta S is nothing but it is a change in distance. represents the ratio of bending of C. C is nothing but it's a curve. So bending of curve between the points P and Q, and the arc length between them. So this is nothing but it is a ratio, so which represents the bending of the curve C. So the bending of the curve C is given by the ratio delta phi divided by delta S. So using these all parameters, now we need to construct the graph. Using the above parameters, now we shall construct the graph to determine the curvature. So first we shall consider the two axes, that is x and y axis. So this is the y axis, and then we shall consider one more axis, that is x axis. So this is x axis and this is the O to be the origin. So now we shall draw a line. So this is the line. Then the angle made by this, consider it as the phi. So then we need to draw the tangent. So this represents the tangent. As we have discussed earlier, so the angle made by the line is phi and the angle made with respect to tangent is phi plus delta phi. So therefore it is phi plus delta phi. And then now we have drawn the tangent and the line, then we need to draw curvature. So therefore now we shall draw the curvature with respect to these points. So now we have constructed the curvature. So this curve represents the curvature, and we have discussed that we need to consider the 2 points, that is P and Q. So therefore this is the point P, and this which is meeting at this is the point Q. So the distance between this, the change in the distance is taken as delta S, and also the change in the distance between the 2 points is delta S. Similarly, the change with respect to tangent, we have discussed that it is delta phi. Therefore, we have constructed the curvature with the two angles phi and phi plus delta phi, and the curvature we have considered the 2 points which will join the line and the tangent. P and Q are the 2 points, and the change in the distance is delta S. Similarly, the change in the distance of a tangent is delta phi. So therefore, rate of bending of curve at P is. Therefore, we need to find the rate of bending of curve at point P. So this is nothing but we need to consider the two distance, delta phi and delta S. Therefore, it will be delta phi divided by delta S is equal to. And then now we need to apply the limit. Earlier we have find the ratio. So that only we have written. That is, earlier we discussed that the bending of a curve, the ratio is given by delta phi divided by delta S. So that only we have considered the rate of bending of curve is delta phi by delta S. So for this ratio we need to apply the limit. That is, limit as Q tends to P. Because we have considered the 2 points, therefore we need to apply the limit with respect to Q, and it tends to point P. That is, ratio is delta phi divided by delta S. So this is the rate of bending of a curve at P. So then the rate of bending is called the curvature of curve C at point P, because we have considered the rate of bending of curve at point P. Therefore, this bending of a curve is referred as a curvature at point P. At point P. At point P, and is denoted by and is denoted by k. That is, k is nothing but it is some constant. So radius of curvature is represented with the curve C. So the equation, the rate of bending, it can be denoted by k. So thus we can write it as k is equal to d phi divided by ds. Then we note that the curvature straight line is 0. This is important. That is the curvature of any straight line. So if you consider this as this is the straight line, so the curvature of this any straight line is 0, because the straight line is always straight, there is no bending of the line. Therefore the curvature of any straight line is 0, since there is no bending. Since there is no bending, therefore we can write it as k to be 0. K is equal to 0. So for a curvature, if you consider this to be the curve, then the equation for curvature k is nothing but d phi by ds. So this is the small change with respect to the change in tangent and change with respect to distance. But if you consider any straight line, there is no any bending of the curve. Therefore therefore equation k will be equal to 0, since there is no any bending. Therefore it is referred as the curvature of a straight line is 0. And the curvature of circle is constant. And it is not equal to 0. That is, the curvature of a straight line is 0, but the curvature of a circle is constant and it is not 0, because the circle, it is uniformly distributed. Since it is uniformly distributed, because the circle, it is uniformly distributed, hence the curvature cannot be 0, it is always constant. That is, it is always constant means the k is not equal to 0. For a straight line, k is equal to 0, but for a circle, k is not equal to 0. Then for a circle, it is k is not equal to 0 will be the equation. So then 1 by k is the radius of curvature. And is denoted by rho. So this is nothing but it is rho in Greek letter. It is referred as the rho in Greek letter. Therefore you can write it as, therefore the radius of curvature can be written as we know that the curvature is given by d phi by ds. Curvature is d phi by ds. And what about radius of curvature? So the radius of curvature, it is denoted by rho, and it is reciprocal of curvature. So it will be 1 divided by k. So if it is a reciprocal, then it will be ds upon d phi. So this will be the equation for the radius of curvature. So that is, the curvature of any straight line is 0, and similarly the curvature of a circle is not 0, it is always constant. Therefore k is not equal to 0. So by using this equation, the equation for the curvature is given by k is equal to d phi by ds. then the radius of curvature will be the reciprocal of a curvature, so it will be 1 by k, and the radius of curvature is denoted by rho. Therefore, rho is equal to 1 by k. So, it will be ds upon d phi. So, this is the equation for the radius of curvature. Thank you friends. Subscribe our channel for more updates.